Here is the reason why division and taking a root, such as square root or cube root, in an equation isn't a good thing. Because, for example, if we're considering the following equation, 2x equals 6 in mod 8, when we try to consider this equation and try to solve this, if we're trying to divide this whole thing by 2, what we are trying to consider of is if we can actually try to factor out this expression. But as we try to factor out a 2, in fact, we actually end up with two options. We can end up with either x minus 3 equals 0, or we have 2x minus 7 equals 0. Now, how do we get the 7 here? Well, in fact, if we are trying to finish our proof and then check our answers, we can actually see that when we substitute 7 into the original equation, we get 2 times 7 is equal to 14, which is actually congruent to 6 in mod 8. And as we can notice, the difference between the two sums will be equal to, the difference of the two solutions will be equal to 4. So what we can see is that when we are trying to divide this equation by 2 on both sides, for 0 or the number or the constant term that we're dividing by, we actually need to consider two cases, either 0 or 8 over 2, which is equal to 4. So that now as we try to add the 3 on both sides, we'll get two different results. Similarly, if we're trying to consider x equals 1 in mod 8, what we are trying to solve is we want to solve x squared minus 1 is equal to 0 in mod 8. But if we are trying to list out all the possible answers, we get 1, 3, 5, and 7. And once again, we can check our answers by substituting back to the original equation to get that 1 squared is equal to 1. 3 squared is equal to 9, which is congruent to 1 in mod 8. Similarly, 5 squared and 7 squared will also congruent to 1.